everyone, we're back. So now we're in lesson 5.2. We're going to generate equivalent ratios. So our essential question is, how can you find equivalent ratios? And we know that we could use multiplication and division to find equivalent ratios. Our overview is just the same. We do lesson exercise 1, 2, and if you could go for 3, we'll move on. All right, so let's start. We always start with solve and discuss. This is a challenge question before we move on to our lesson. So Sally used all the paint shown to make a certain tint of orange paint. How many pints of red paint should be mixed with 24 pints of yellow paint to make the same tint of orange? Solve this problem in any way you like. So good luck. I know this is fun. Go ahead. Let's look at example number 1.
Equivalent ratios. Think about this question during the lesson. For every 16 basketball players in Crystal County schools, there are 48 soccer players. If the ratio remains constant and there are 64 basketball players, how many soccer players are there? What two quantities are being compared in this problem? How would you write the ratio relationship?
So since we know that we could write the ratio using a fraction, we could use that, right? So on your own way, how do you think you could use this relationship between the basketball and the soccer players to figure out the answer? Let's play along.
The quantities being compared are the number of basketball players and the number of soccer players. You can write the ratio relationship as 16 to 48, 16 to 48, or 16 over 48.
So remember, we've been using 16 to 48, but I recommend that you write it in the form of fraction so that it's easier for you to create equivalent expressions later on.
Here is one way to solve the problem. You can use the structure in a ratio table to find equivalent ratios. Make a table with equivalent ratios. Remember, multiply both terms of the original ratio by the same number to find an equivalent ratio.
So we did this in the beginning. So if you multiply the numerator, so let's say that's your numerator by 2 or by 3 by 4, you remember that you have to do it the same way in the denominator.
There are 192 soccer players when there are 64 basketball players. Here is another way. Use multiplication. By what number should you multiply both terms to find an equivalent ratio that compares 64 basketball players to the unknown number of soccer players?
So here you know that you could multiply
Select
16
your answer.
by what number to get 64, and that will be the same number you gotta multiply to 48 times equals what number? Okay, if you said your answer is 4, I think you got it correct.
Multiply both terms by 4. 16 over 48 and 64 over 192 are equivalent ratios. Why does multiplying both terms by the same non-zero number result in an equivalent ratio?
All right, so do you guys remember what we have this before? How do you say 4 over 4 in other terms? Okay, so if you said that is equivalent to 1, so it means you're just multiplying this number by 1. So they are equivalent because the value doesn't change. All right, so let's check.
Any non-zero number divided by itself is 1. So it is like multiplying by 1 whole. Multiplying by 1 does not change the value of the ratio. There are 192 soccer players when there are 64 basketball players. Now you know how to find equivalent ratio.
All right, let's extend. If you extend the table, how would you find the next ratio of the basketball players to the soccer players? So let's say, how about if there are, if you double the number of soccer players, how many number of basketball players you have? Go ahead. All right, let's move on to example number 2. So Sarah made a basket on some of her shots in a basketball game. If she continues to make baskets at the same rate, how many baskets Sarah will make in her 6 shots? So this is what Sarah is doing. 18 shots and 12 baskets. So let's see. Go ahead, try. So we started with 18 and 12, but we were looking at about 6, right? So we could go back by dividing it by 2. So to make 9, and we know that you could also divide it by 3 to get 6. So what will you do with 18 to make it 6? You divide it by 3. So that is also the same way when you do with 12. If you divide 18 by 2 to get 6, you're going to have to divide 12 by 3 to get 4. So Sarah will make 4 baskets in her 6 shots. Okay? Alright, I want you guys to try this. Rashida uses 8 cups of tomatoes and 3 cups of onions to make salsa. How many cups of onions should Rashida use if she uses only 4 cups of tomatoes? You could create a table, you could create equivalent fraction. Good luck on whatever way you want to solve this problem. Alright? Alright, let's work on example 3. The circumference of a circle, which is letter C, the circumference is the measurement around it, is the distance around the circle. The diameter of a circle, which is D, which is the one that's across it, is the segment that passes through the center that has both ends at the circle, so it touches the circle. Pi, on the other hand, is pi, or this symbol, is the ratio of the circumference of the circle to its diameter. This ratio is approximately 66 is to 21, which is the following ratios are equivalent to this way. Okay? So we'll make an equivalent, make the table to equivalent ratio, or we make a table. You could extend that if you want. So I want you to try this. Which of the following ratios are equivalent to 16 is to 20? So which of this is equivalent to 16 is to 20? And how do you know that they are equivalent? So make sure that you know how to reason out later on when we'll discuss, alright? So if you said that they have the same value, then you're correct. If you say that you're just gonna simplify them with 1/1 or 4/4, or you're simplifying it with 1, even though it's 4/4 or 5/5, it's still equivalent to 1, then you're correct. So as long as the value stays the same, then they are equivalent. Okay, that's why they are equal. Alright guys, we're moving along. I want you to go to page 266 and work on do you understand and do you know how page. And then if you have a question, we'll discuss this a group later on. Alright, so go along and good luck. I'm gonna go around and check your work. Alright? Alright guys, we are at the end of this lesson. I want you to do your self-assessment, and we'll check tomorrow or next period when we come back what we could do more to practice creating equivalent expression, equivalent ratio, or in simply equivalent fractions. Good luck for now and have a good day. Enjoy. Bye. Until next time.